So after you've got your near-term and long-term goals defined, you've made some deliberate selection of parents in a crossing program, you've generated some new variation, then it is necessary to begin to develop and identify desirable genotypes. I don't think I'm telling you anything new here, but you now have to decide on a breeding methodology that determines how and when you'll begin the selection of those desirable genotypes. You can develop your own method, or you can go to the textbooks that I showed you and you can initiate one of those traditional models. The objective is to do the inbreeding, to inbreed lines with the purpose of developing genotypes that are stable and will be maintained through many generations of seed multiplication. The coefficient of inbreeding is a statistic that helps describe the degree of relationships in that inbred population. That coefficient varies from 0 to 1, depends on the number of generations of inbreeding. In my case, I always went to an F4 generation before I would begin selecting inbred lines. You may have some other methodology, depending on your breeding program and the particular cross that you're working with. You may decide to start selection in the F2 generation. So these are some of the methods most commonly used in selfing germplasm. The one that is often used is the bulk method. So we make a cross, an F1 cross, we plant the F1 seed, harvest the F2 seed, we plant the F2 seed, harvest the F3 seed, plant the F3 seed, harvest the F4 seed, somewhere in there. That's the bulk method. You would begin selecting single plants that would be homozygous enough that they would retain the trait of the line, whatever you selected. Then there is a single seed. Well, the selected bulk method is the one that Joshua was telling you about. Many of you likely know it or are practicing it. And I've got a little more detail on that. Single seed descent method is another method for selfing germplasm. Has anyone ever used this particular application? Yeah.
Yeah, for the
mapping populations, that'd be a good use of single seed descent. Mass selection, pedigreed selection, genomic selection. Who's practicing genomic selection in here? Anybody? It's all the rage. So here's an example of the bulk and the selected bulk methods. F2 plants grown and F3 seed harvested in bulk. A sample of all that F3 seed is planted again, and F4 seeds of the population are harvested again in bulk. So you've made no selection there. This is repeated until you get to the desired level of inbreeding, and then individual plants are selected from the homozygous but still heterogeneous population, and they're maintained then as individual lines. And then these pure lines typically go to an observation nursery or some other such nursery where they're continued under evaluation for whatever the traits are that you've defined in the program. So this is the CIMMET selected bulk method. And in this case, these plants have all been tagged in a segregating population. Those plants are in an F3 population where the tagged plants are resistant to stem rust. Those plants are harvested, threshed, and bulked into an F4 population. So the selected bulk method means it's been selected for resistance to UG99. They're all threshed in bulk, and they form a composite that is then planted again in Kenya, and the resistance plants tagged again. Those tagged plants are again harvested, threshed, and the selection bulked again. And that bulk then goes to Mexico for planting and selection of individual plants. The CIMMET selected bulk method. The single seed descent method, the classical procedure is you harvest a single seed from each plant in the F2 population. If you've not done that, it's a lot of work. And then all of that F3 seed is put into a bulk. That bulk is planted again, and again a single seed is harvested from each plant and bulked to form an F4 population. That procedure is repeated until the level of desired homozygosity is achieved. And at that point, you would select individual plants and derive individual lines from them. The objective of the single seed descent method is that there is an effort to maintain the genetic variation within the population and go to homozygosity while retaining the maximum genetic variation within the population. I don't know of too many people who use it because it can be pretty intensive, but for specific traits, it can be quite effective. Mass selection. So many of the early corn varieties, maize populations, were developed in the USA. From an initial population, desirable plants are selected and composited, bulked together, and there you have it. That's your new variety. They are developed with fewer genotypes than the original population. These were often land races. And I think most authors would suggest that that procedure eliminated plants of low agricultural value and formed a new plant population or a new variety. Pedigreed selection. So if you have an F2 population that would be space planted, that would allow you to select individual plants. From that point on, those plants are maintained separately. They are not composite into a bulk. The F3 seed from these F2 plants could be grown in a row. The best rows are then selected, and the best F3 plants within these rows are harvested. And then the F4 progeny from each F3 plant is grown in a row alongside other plants from the same families, and then the best family or families are selected, and the best rows within the selected families are identified, and the best plants within the selected rows are harvested. And then lines are derived from F5 plants and continue to be evaluated for traits of interest. Does anyone here use a pedigreed system of plant breeding in their program? Selected bulk, yeah. In my program,
mostly followed by CMIT.
Yeah.
What is the advantage of select bulk over a pedigree?
Good question. This is what I do. This is what I prefer. So my argument is if I harvest an ear, every seed on there is related. It's from the same plant. And so when I want to keep that as a separate genetic package, there will be a relationship between all of the plants that come from that ear. If they're put back together in a bulk, it's easy to handle. The selected bulk method can handle lots of germplasm very efficiently. I have what I called a poor man's pedigreed system. So I would not, I had a system that allowed me to handle a lot of ears and maintain the individual plants until I got to this generation. And I found it to be more efficient for me than a selected bulk method, for example. I think what is important is that you believe in whatever system you're using. If somebody tells you to do it and you do it because that guy thinks I should, but I think I should do it this way because it's better, I think whatever you do, if you don't have the commitment and the belief in it, you should be doing something else. For myself, I really like this system, and I would use it again. This is new. Genomic selection. Have you heard of genomic selection? Has anybody heard? Everybody's heard of genomic selection? Yeah. This was the publication that started it all in 2001. In fact, it's on your flash drive if you care to read through it. I tried once. Too much math for me. There's information at the DNA level that will lead to faster genetic gain than achieved with phenotypic data only. The approach is to estimate the effect of small chromosome segments defined by marker alleles on the expression of a quantitative trait. And so the selection is based on a small chromosome segment. And that this is now possible because DNA chip technology is making it feasible and cost-effective. In fact, the Cornell DRRW project supported a graduate student to investigate genomic selection for adult plant resistance. And that paper also is in the package if you care to study it.